Okay, grab the TI programmer from the TI programmer box. Make sure it has this connector on it, and then also make sure it's plugged in correctly. The red pin goes to the black mark, and then go to the computer over here and plug it in. Then it should find it and it's ready to run. And then you want to click, we're in the 8S DTS directory, and then click Program Flash. And then it brings up the program. The firmware is 121 DTS. And next, you want to go to the DTS box right here. You're going to hook up the voltage reference. It just plugs in right there. It has two connectors on it. A small one, this is for the old 6S, and that connector. Okay, on the board for testing, to ready it for testing, make sure you have the output connector connected, all soldered up, and then you're going to connect the reference voltage connector, and you're going to solder those wires one at a time. Pin 1 is the black wire. Make sure it's disconnected when you're soldering it, and then solder all 8 wires and the thermistor. Make sure you solder that in, and then you're going to be ready for programming and testing. While you're waiting for these boards to test, on another board, do the X-Acto pin lift on all the fine pitch pins there. Just lift them all. Also, use a magnifying glass and look really close at the fine pitched, especially the little transistors, and look close at those. Make sure they're all soldered. If they're not, you got to touch them up. Those are the common places that have problems on the board. So now you power up your power hooked up to the reference voltage. Your output, plug that in, connect to port 1. Make sure your switch is on the on position. And now the board is powered up, ready to test. We got our tester software running right here. Now the programming software, you run that by clicking on Program Flash. And then we're going to use the Auto Prog button. So we're going to go over here, match pin 1 to the square. Pin 1 to the square. Gonna put a little tension on it, and then click the Auto Prog. And now I'll notice that finished programming. As soon as it finishes programming, just go ahead and remove the connector, and it should start testing automatically. And our mode started in 1, and now it's in mode 2, and here's our test count. Now you want to check that the LEDs are working. So the first LED came on, the second one, now the third one's coming on, and we're going to have the fourth LED come on in a second here. If the test error's out, try doing a retest by resetting the board, and you can do it with it connected. It's going to be the center pin and then skip 1. So you're going to hold those and just go ahead and hold them shorted together with the tweezers for about 10 seconds, and then let go, and it'll retest. What happens when you remove the programmer, sometimes the processor gets blipped into a soft start and the tester doesn't like it. So by holding it and then releasing it, it'll restart the test, and a lot of the baddies will mysteriously become good that way. When it starts testing, it goes and starts calibrating all the cells. Make sure you got the 6 down there in the bottom, or it'll program 6 cells. And then you want to check some voltages on the FETs, and once it finishes programming here, you need to check that the balance is warm. There's just one of them you have to manually check that it's warm. During the test, you want to check the voltage. Use the HP meter and check the voltage from ground, and then use the red lead. You're going to check pin 1 of both of the FETs, and so one of the FETs and will be 0 volts, and the other one will be 14 volts on pin 1. And you do that while it's testing. You have time. So now it finished doing the calibration. Now it's running balance number 1, because when it's bold like that, that's the balance that it's on. And you want to verify that this balance right there is warm. It's very subtle. This is the only one. I usually use my upper lip, and I can feel it real easily. So that tells you the balance is warm. The rest of them will automatically check by themselves. And then you want to verify the voltage. Here it's prompting you to verify that it's warm. But whenever you see it, whenever it's bold there, number 1, that's the only one. The rest of them are automatic. You don't have to check temperature. Now at the end of the test, notice it said programming 6 cells. You got to make sure that's set to 6. And then it said passed. So it's passed the test. So first you want to disconnect the power supply. Right there. And then you're going to disconnect the output connector, and then you're going to unsolder the wires one by one. It's helpful, put another BPM right next to it, and then you can move each wire one at a time, soldering it, unsoldering it, and soldering it, and you won't mess up any of the wire orders, and you don't have to think about the wires either. And then also the thermistor, make sure you move that to the next board that you're going to test. And then since it's passed, on the bottom, you flip it over. It's the bottom right side, right next to the programming connector. You want to write V1.21. So V1.21. And then that shows that the board's been tested and programmed, and that's the version of code that's in it. Now I want to show how to do a final check on these BPMs, and you want to check the voltage on pin 1. You need 14 volts on both of the FETs. You want to hook it up to the PC and just run the BPM viewer, which is right here. It's going to show you the health. All cells are good. And it's showing it had a system reset. You can clear that out by just doing another reset on it. And reset is always the middle pin, and then skip 1. So we're going to do the middle to here. Just sort those together, and you just wait for a second. And you release that. And you clear it out the system reset there. That happened when it was being soldered together. And so everything looks good. Make sure all your cell voltages are good. There's no errors. And then just do a quick lamp load test on the output there. As a final check, use the clamp on current meter and check each wire, including the large wires, and make sure that they're less than 0.1. If it's reading out, this is going to be noise, this 0.2. You can periodically re-zero, so take it off, close it. See, I'm still reading 0.2, hit the 0 button. And just go down. If you're 0.1, that's fine. 0.0, you know, whatever, that's just going to be noise, don't worry about it. If you have a bad BPM with a bad part, you're going to be really high, like 10, 20, 30 milliamps. And you're just going to verify, you know, that it's 0. Sometimes the balancers might be on. You might see 100 milliamp if the balancer's on. Come back and make sure the balancer shuts off. And that's it.